Project 5-7 is one of those interesting pieces that it's going to be able to move, and it's going to move in interesting ways, and we're going to probably see a little bit of interference at this edge. But depending on how I make these mates, I expect a lot of movement out of this part. So we're going to do that on purpose so that we can see, and maybe throw in a couple of the other distance mates or angle mates, depending on what we can utilize. Alright, so we'll go back into our assembly. This should be getting into the habit of we're always opening up the module that we need, and then we can browse to our item, the spacer plate, and this is going to be a quad. And when I open it, and this one, let's see, position wise, let's go rotate around Z and then rotate around Y, and that puts it in a rough position. And really don't care if it goes to the origin, because we kind of already decided that it's not going to. And then we'll go to the right plane to the face, and then I'll put that to the front and sketch, and then the last would be the bottom of the part to the top plane. And we'll set our initial piece. Alright, so then we have an L bracket and then a series two Z brackets back to another quad. Alright, so we'll push that back out of the way, and we'll bring in a bracket. And the L bracket comes in, and because of the mate reference, it's going to jump into position. And we're going to see how this is going to work with the other two. So if I go to that way, then I can go back and pick the Z bracket. Okay, so that gives me the next position. Hold down the control button until it finds, it's losing its mind here. And I'm able to really not going to zoom up. Well, looks like it's still trying to find that one face. Not my preference, so since it's not going easily, I'm gonna leave it, and we'll go apply the mates manually. So I think I got the two faces now just highlighted. Make sure they're both in blue, and we can already kind of see how it's going to be moving as we go through this process. So set that to coincident, and then I'll bring this one over. Stays in the same relative position as the seed part, and then we can go concentric and coincident. Alright, so those little guys, and then as this rotates around and my video card freaks out a little bit, we're going to get some different possible solutions. So the last mate would be to bring this, and we'll see if it solves. If it can't go coincident, then it would be one that might have to go parallel. Alright, so can't find that one. So let's see if there's a little bit of a gap there on our stack up that it can go parallel. So it went the wrong way, or not the way that I wanted. And we'll right click. So I'm expanding out under the spacer plate, and then finding the parallel, and then when I flip the mate alignment, that'll bring it back around. Alright, so now the process is to get these to straighten out enough and see all the possible rotations and gyrations that it can go through. Alright, so since that's way too much fun, I'm going to set a few angles on this one just to be different. The solution would be to apply a mate, and then we have a multi-mate. Alright, so multi-mate mode, I have the one base, and then I would go through and I would pick all of the faces, and as it finds those coincidences, then it comes up with a solution. Alright, so that would be enough to to solve because all of that comes back in. And since I've got that, let's see if there was a gap there or if it actually lined up. Hard to tell. If there is, it's a really minor gap. So let's see if I can find that point and select. Then we will go into the measure. So under evaluate and go into the measure tool. We'll expand that out. And it says they intersect. So it makes sense that it would line up, and then 1, 2, 3, the offset. Yeah, makes sense. And if we look at it from the top, it doesn't quite line up the way I expected it to, but we're there. Alright, so those last 2 or 3 mates, the coincidences, expand those out because I don't want to open up each part and track it down individually. We'll go into the list, and it's holding down the shift button, so let's see if I can get all 3. Alright, I think my computer is still wound up here, so as I suppress those, now this is also, I don't want to get into configurations just yet, but if I wanted this to be one solution, I could set a configuration as everything's in line. And then as we went through and picked, if I was setting distances or angles, I could have another configuration that was angled, and that looks okay, where I can flip the dimension, or we can, if we flip the alignment, it will bring it back over to the next solution, either to the adjacent angle or to. Let's see, so that one's at 160. Let's see, 135 and 15 would be 150 to get it to 15 degrees. All right, 160 is okay. We'll just even it out a little bit. And then if we go to this one, let's bring that around. And if I go to its mate, then we have, we'll go to 150 there. And we expect to still have a little bit of interference there, and the only real reason is that I expect that it will not like. So the spacer plate, since I need to identify it by itself, we have concentric and coincident to the face, and then it's remaining parallel to something. Alright, so in that case, if I suppress that parallel, that should allow that to move. Alright, so hopefully you get a sense that we can build up the logic, and even though we're constructing and deconstructing as we go, we can get these various solutions. Alright, so didn't like my angle there, even though it can fully rotate. And it should be absolutely able to pick up the angle between those two since the faces are coincident. Alright, so we got a preview that time instead of 0, so let's just go 30 degrees, it rotates to position, and we have it. Alright, so getting kind of a weird shape, that goes to our position, and then when we start talking about the CSWA, we know that the origin is back over here somewhere at the base of the part. If I go into the mass properties, then my total mass, 146.43 grams, and the center of mass would be at 50.4 in X, 62.3, 7.95. So when we're looking at that in relation to the origin, and then our moments are basically off of that center of mass location. So it makes it a little bit more interesting than just having everything stacked up straight up and down. Alright, so the pegs, even though the pegs are not really an issue, we do have a collision. Alright, so that would be something that can't get to that point. The rest of these can, but that's going to be a no-go. All right, unless we round that over or do something with it that it has the relief, then I just can't get to that position. So one of the things that we could check for is if we do interference detection, then we do a calculate, and it found the interference, and it's showing me where that overlap is, and then it should also be telling me how much. So it's giving me a volume of how much overlap we're dealing with there. Alright, so it looks good. I'm not going to play with it anymore. If you put everything into that first, I should have noted then that doing all this is optional. These are for examples and to kind of give you a sense. Alright, so I will say if you have everything straight up and down here, that is fine. We're going to insert the components. We'll bring in the peg. All of our pegs should be 20s. And then a tab. And if I do enough of these pegs, at some point I'm going to want to see about putting this in the design library so I can continue to drag and drop the component instead of picking it every time. Oops, and there I let go a little bit too soon again, so drop, tab, let go of the mouse button, then let go of the control button. Alright, one quick save, and we have our assembly 5-6, or 7. Alright.